I call this an affinity test because it assesses whether or not there is a true deep bond among three individuals. Okay? So we need 9 random cards for this effect. I suppose you can also call this the not the 9 card problem. Okay? Why do I say that? Well, there's a classic effect involving 9 cards that people have used, and this is not it. This is brand new. Okay? So no one has seen this before. In fact, a vast majority of the card effects on my channel have never been seen before. Okay, so we need 9 random cards. So I'll just start dealing the cards from different different places. 3, 4, 5, 6, 7, 8, 9, and maybe one from the bottom. Okay, 9 random cards. We don't need the rest. We'll set them aside out of the way. Okay, and then we can mix these two. Okay, so these are truly mixed. And then we'll set them out into 3 piles of 3 cards. Okay, so sorry, I'm more time. It's a brand new deck, so it's sliding everywhere here. So maybe these are for spectator 1, 2, 3. Oh, very good. Looks like we have 1 extra. Okay, because I couldn't count there. So now we have 3 piles of 3 cards each. Okay, so now what you need the spectators to do, or you can do it for them, I suppose, is spectator 1 needs to pick up their little pile, take a look at the identity of that card without showing it to you or the other 2 spectators. Okay, now because I don't have spectators here, I'm going to have to actually write down what these are. Well, I guess we could maybe remember 3 cards, but let's not overload our brains here. Okay, so we know that spectator's first card is the 5 of diamonds. Now spectator 2 will take theirs and surreptitiously look at it without showing anyone else. So it looks like the 7 of spades. And let me just write that down. 7 of spades. Okay. And then spectator's 3 special card. What's that? Oh, 3 of spades. You can see that? 3 of spades. So let's just jot that down. 3 of spades. Okay. Very good. Okay. And now you can have the spectators dictate how these are stacked. Maybe spectator 2 wants to go first, then 1, and then 3. Okay, very good. So what you do is you turn to spectator 1 and say, okay, we want to randomize these cards. Okay? And would you like me to deal out into 2 piles, 3 piles, even 4 piles if you'd like? And so maybe they'll say 2 piles, okay? So we'll deal them out into 2 piles, okay? How would you like these stacked? Right on left or left on right? You want right on left, okay? Would you like to deal into 3 piles? Yes, okay. Let's deal into 3 piles. How would you like me to pick these up? Middle one first, one on the right, and the one on the left. Okay, why don't we also deal into a triangle? It seems to have kind of remarkable properties here. In fact, what we can do is actually allow you to tell me, like, where do you, we'll build up 3 levels here. So where do you want this one? Over there, and then this one here, and then that one there. How about this one? Down below, and on the right, and then on the left. How would you like me to pick these up? Top right, bottom center, top left. Okay, great. Well, you've made a lot of choices there. Spectator 2, would you like me to deal into 2 or 3 or 4 piles? 2 piles. Okay. Would you like me to stack left on right or right on left? You want left on right? Okay, very good. Any others? Another left right. Okay, that's a little different. How would you like those stacked? Left on right again. Okay, no change there. Okay. Any others? You're satisfied? Okay. Well, I was actually hoping for you to ask for 4 piles. We don't have to do it, but just for fun, why don't we do that? We'll deal out into 4 piles. And just in an effort to really mix these cards beyond the knowledge of anyone, okay? And then spectator 3, what would you like me to do? 2 piles? You want right on left or left on right? You want right on left. Okay, very good. Sorry, I pulled that off the table. I shouldn't have done that. We can also do something called a Pharaoh shuffle, if you would like. Have you heard of the Pharaoh shuffle? It's kind of a famous shuffle. You'd like to see that. Okay, so how this works, in fact, for the magicians out there, the reality is you never Pharaoh shuffle an odd size packet, period. Okay, that's a little note to the magicians out there. But we're going to do it nonetheless. Okay, and why is that? Well, it's because an odd number is not divisible by 2, right? Okay, so what that means then is we're going to have to take like 5, 1, 2, 3, 4, 5, and then 4, okay? And then what we do is you just perfectly interlace them, okay? And we can do that still if you're, careful, okay? So that's a Pharaoh shuffle. Would you like to deal out into, 3 piles? You would. Okay. Doing 3 piles. How would you, spectator 3, like these stacked? You want this one first pile next, and then the middle pile. Should we also do the triangle? Just, kind of just for, well, in fact, sorry, I keep forgetting to give you choices here. So where would you want this one put? Down there, and then on the right, of course, we finished that level. What about this one? Top right, top left, center. Okay, how would you like me to pick these up? Okay, bottom, top left, top right. Okay, wow. Now, do any of you want me to do any more, dealing into 2 or 3 or 4 or a Pharaoh? Just one more left, right. Okay, great. How would you like these stacked? Left on right? Okay. And I even forgot to, we don't need to do it, but this is just for you when you go to perform this. I forgot to actually mention that you can actually do even or odd up jogs. Okay. So is anyone interested in seeing that? We honestly don't need to do it, but I just want to show you it if you're interested. Okay, so an up jog. So how this works is you can push forward, let's say the even position cards, like this, even position. And then what you do is you strip them out and then randomly stack those 2 packets together. Okay, so that's called an up jog. Okay, and we can do as many of those as you like as well. You'd like to do one more of those? Okay, that would be just fine. I guess it would give you a second chance to see it in action, I suppose. Okay, just strip these out. How would you like these stacked? Left on right? Okay, wow, we have done a tremendous amount of mixing. So I really think the universe can now freely and accurately communicate to us whether there is an affinity among the 3 of you. So all I'm going to do at this point is I'm going to deal out the cards into 3 piles, okay? Kind of like we started, I suppose, just 3 piles. Now, what I need you to do is I'm going to show each of these piles. We'll kind of just show them all at once, I suppose. Well, not at once. I don't have 3 hands here, but I want spectator 1 and 2 and 3 to quickly identify which pile contains your card. Okay, so I'm going to go with this one first. Okay, so here's pile 1. Okay, so each of you, each spectator is supposed to be kind of looking for your card, if you can find it. Here's pile 2, and then the final pile. Okay, I'll have to put it down here to stay on camera here. Do the 3 of you see which pile has your card? Can each of you point to the pile that contains your card? And if I had 3 fingers, there you go, 3 fingers. They're all going to point to this pile here. Okay? So at that point, you can say there's no way. You guys, despite all of these random choices and random processes, have indeed passed the affinity test and have been proven to be intrinsically bonded to each other. Okay, so that is the fact, and this will work for you, of course, every time. Why is that? Because of mathematics, it will. Okay, so let's talk about what's going on here, maybe in some ways so that we don't have to write down new names here, I suppose. Okay, so let's put this one, so this 5 of diamonds, kind of go back in time, not really, but a little bit. Okay, and then maybe 2 here, 2 there, 2 here. Okay, so get to the point where you have the spectators freely select a pile, one pile per spectator. Have them look at the bottom card, note it, okay, but don't show it to the others, including you as the performer, okay. So that's kind of where we are here. Okay, so what is going on here? Let me just bring over, okay, so maybe I'll put 1 pile here, 1 here, and 1 over here in the center, okay? So I just want to show a short write-up of what's going on here, okay? So what makes this work is we have an odd size cyclic packet with an odd number of cycles, and each cycle is of an odd length, namely 3 for both. So this is a 3 cycle with cycle length 3. That's how we get the 9 cards. Okay, so what I've done is I've kind of written down the archetypal 3 cycle with cycle length 3. Okay, so I have like a 1, 2, 3, 1, 2, 3, 1, 2, 3. Now, if you think about it, we did not fully take advantage of the structure that's being preserved within this presentation, okay? Because the fact is we could have had an ace 2, 3, ace 2, 3, ace 2, 3, gone through all of these steps, and at the very end you would have 3 piles of 3. One would have just aces in it. The second pile might have just the 2s, and then the third pile would have just the 3s, okay? So we in no way took advantage of the full invariance of this particular structure, okay? So we simplified it down to just being concerned about preserving the relative positions of the initially bottom card of each packet of 3, okay? So we essentially put the spectators' cards in a cyclic configuration relative to each other, and then we ignored what the top 2 cards were on top of each of the spectators' cards. Now, like I said, you could take advantage of the fact that you're preserving those relationships as well. Like the top card of each will be preserved in some way in terms of a set of cards. The second card's down, the same thing, but we are only focused on the third card, which is fine. And there's some power in not taking advantage of the full invariance of a packet of cards. Okay, so here we're only focused on the bottom cards. Now, when we stack these, now the important thing is it doesn't matter how we stack these. Okay, remember, spectator cards are on the bottom, so you can have the spectators decide how these are stacked. Well, no matter how those sets of 3 are stacked, it's technically a cyclic construction relative to the location of their cards. In other words, it's a 3 cycle with cycle length 3. Okay. Now, this kind of structure is invariant under the following mixing procedures, as well as others, of course. And I don't know that this is well known. I've never seen anyone document this. I don't think I've seen anyone take advantage of this invariance. I truly haven't. Of course, I haven't seen every card effect in history. But this is a remarkable property of odd size cyclic packets where there's an odd number of repeating cycles with odd length. Okay, isn't that interesting? Okay, so the first invariant mixing procedure, or in other words, the first mixing procedure that will preserve the cyclic structure here is a simple left-right shuffle with random stacking. Isn't that nice? Okay. Now the cards, the 1, 2s, and 3s. Now technically these are different cards. Like maybe this is 1, 2, 3, and then this is like 1, 2, 3, little apostrophe there, and maybe there's 2 here, little prime symbols here, double prime there. So technically those 1s are all different, the 2s are all different, and the 3s are all physically different. And the point I want to make is, with these shuffles that, quote, preserve this structure, the 1s are switching places with the 1s, the 2s are switching places among themselves, and the 3s are switching places among themselves. And then you even have a whole cell moving around of blocks of cards. For example, after a shuffle here, it might be 3, 1, 2, 3, 1, 2, 3, 1, 2. And then these little primes may have moved around to different values. The cards will likely get permuted, okay? But the thing that is preserved is the fact that there is a repeating pattern of the card values 1, 2, and 3. There's going to be some kind of pattern. Maybe it's 3, 2, 1. 3, 2, 1, 3, and that will repeat 3 times consistently, okay? So that's what we mean by these shuffles preserving this 3 cycle of cycle length 3, okay? So the point I was making here is you can perform as many LR shuffles with random stacking. That's wonderful. Up jogs, like I showed you, with random stacking. Now you can perform ferrules as well, okay? And I guess I kind of explain that within the video itself. But because we have an odd number of cards, you're going to have, if you're going to try to divide it roughly, in half to the degree that you can, you're going to have 5 and then 4. Well, the key here for the ferrule to work is the 4 over here need to be completely interlaced into this larger packet of 5. So for example, there's only 4 here, so I'd want that one there, next one goes there, next one there, and then this one here needs to go under that one there. Okay, so it's kind of a qualified ferrule shuffle, but it's a reasonable definition for a ferrule shuffle when you have an odd number of cards. Okay, so that's not really a big surprise. Now, really, one of the caveats to be aware of here for dealing out into 4 piles is technically you do need to stack from left to right to preserve this cyclic structure up here. Okay, and if you go back to the performance itself, you'll notice that I just kind of threw in one and said, you can actually deal out into 4 piles, and then without really making a big deal of it, I just started to stack from left to right. Okay, because in that particular case, I really cannot safely give you the choice to go from left to right or right to left, because if you go right to left, it destroys this 3 cycle structure. Okay, and then the other dealing that we did, which is most remarkable, is we dealt out into 3 piles. Okay, now it ends up that if you deal out into 3 piles, so we'll kind of do it systematically at 1, 2, 3, 1, 2, 3, 1, 2, 3. You can actually randomly stack these, which is what we did. Okay. But it has changed the structure of this packet. It's no longer a 3 cycle. But if you perform another dealing into 3 piles with random stacking, amazing, it will take it back to the original 3 cycle structure type. Okay? Now, if you do all of this with the cards face up, you can kind of see what's happening with the transformation of the different structures. And I encourage you to do that because it will give you a feel for what's going on and give you confidence. Yes, this will always work, right, in this case. Okay? And then one final amazing thing here. I did 1, 2, 3, 1, 2, 3, and then random stacking. That's like the first dealing into 3 piles. And then I did a triangle. You remember that? For this second dealing into 3 piles, it ends up that you can do what's called an RLR. See that? RLR. R is for random. So what that's referring to is once you've built up one level, you can actually now build the next level in whatever order that you like. Okay, that second level's done. This can go anywhere, and this one as well. Okay, now you can't do that with the first of the two dealings out into 3 piles. Okay, so you need to consistently go like 1, 2, 3, 4, 5, 6, 7, 8, 9, and then randomly stack those 3 piles. The second dealing into 3, you're given quite a bit more freedom actually as to how each layer is built. Okay, now if that's a little bit confusing, what you can do is just remember that you can always deal out into 3 piles, if you want to just leave it in a line here, with random stacking. Wonderful. But you do need to follow that up with a second dealing out into 3 piles. Okay, and if you do that with random stacking here, you're safe. It takes you back to the 3-cycle structure type that we started with. Okay, so now think about the finale. If we have something that's like this, there's a repeating pattern. Maybe it's 2, 1, 3, 2, 1, 3, 2, 1, 3. If we go through and deal out into 3 piles, you remember how I did the final dealing, like spectator 1, 2, 3. Okay, what we will be doing is separating the, quote, first cards in each cycle into 1 pile, the second card in each little cycle into the second pile, and then the third card in each cycle into the third. Well, what does that guarantee? It guarantees that the original bottom cards that they happen to have looked at, right, at the bottom of their little packet, they're all going to be grouped together. Now, we won't necessarily know which one will contain the spectator's cards, and that's actually not important. Really, it isn't. It was serendipity that the last pile in the performance that I just finished came out to be the special pile that contains all 3 spectator cards. That was just serendipity, but it's not necessary, because all you do is you show the cards. And, you know, this really won't mean anything much to anyone. I mean, all the spectator is doing is they're trying to identify, okay, where's the card I remember, you know, that I saw, you know. Each one of them is doing that. And since they don't know what the others had as their card, they won't even see anything funny. And so what you could do actually is you could say, okay, spectator 1, can you point to the pile that contains your card? Okay, and so maybe they'll point to, you know, these cards have been scrambled all over the place. Maybe they point to this one here, and spectator 2 and 3 are thinking, ooh, what's going on here? And then you ask spectator 2, well, which of these piles contains yours? And they'll probably reluctantly go, it's the same pile as spectator 1. And then spectator 3 is thinking, man, oh man, what's going on here? And you ask spectator 3, well, which of these piles contains your card? And they're going to go, the same one. And all 3 of them are going to go, how in the world is that even possible? Well, it's because the universe is communicating to them that there is a special affinity among them. Okay. But really, it's just mathematics driving the whole thing. Okay, so I thought I'd show you this quick little effect. Very, very powerful. It gets a wonderful reaction from the spectators because they just can't see how all of the free choices that each of them are given, where each one of them really has no idea what the other is going to ask for in terms of mixing procedures. And despite those 3 sets of kind of random choices made by them, somehow their 3 cards have congregated together, kind of proving the point that there really is an affinity among them and that they've passed this affinity test. Okay, well, thank you for watching, and take a look at other videos on the Hidden Structures channel. And if you haven't, please subscribe and click like if you enjoyed the video, and I hope you'll take a look at other videos on this channel. So thank you again.